After arithmetic sequences, we talk about geometric sequences. And the difference is with arithmetic sequences, we add or subtract to get from term to term. Here with geometric sequences, we're going to multiply or divide to get from term to term. And instead of having a common difference, we're going to have a common ratio. So we're still looking for that pattern, except now we're looking for a common ratio, and we're going to note that as R. So R equals the common ratio. And I want you to look at these next four sequences and determine whether they're arithmetic, geometric, or neither. If you determine them to be arithmetic or geometric, identify the common ratio or the common difference. Pause here and continue after you've answered the questions. So as you can see, we have two geometric, one arithmetic, and a neither. If you look at the geometric, we have R equal to 3. We're multiplying, and even though it looks like we divide by 1/2 or -1/2 each time, we don't write that as division. We write that as -1/2. So we're actually multiplying by -1/2 each time. And then our arithmetic, we're adding 4 each time. If we have neither up here, because we go 1, 2, so we add 1, and then we add 2, and then we add 6. There's no pattern here. There's nothing going on, so that's neither. So let's look at our formula and our rules for geometric sequences. So just like with arithmetic sequences, we had a rule for the nth term, and we have the same thing for geometric. Same variables. We have a sub n for our nth term, a sub 1 for our first term, and now R is our common ratio instead of D being our common difference. We're going to solve these problems the same way. You're going to be using these formulas a lot. So let's look at our first example. We're going to write a rule for the nth term, and these are fairly simple. I think you'll find them easier than arithmetic to begin with. So let's look at our first example. We're writing a rule for the nth term given this sequence. The first thing we need to figure out is what is our common ratio? How do we get from one term to the next? Well, from 5 to 10, I multiply by 2. 10 to 20, I multiply by 2. So R is 2. And it's pretty straightforward to see that the first term in the sequence is 5. And that's all we need. We have our ratio, we have our first term, so we can write out our sequence. Let me just go ahead and post this formula again right up here. So this says a sub n equals a sub 1, which is 5, times R, which is 2, to the n minus 1. It's important that you leave this as 5 times 2 to the n minus 1. You cannot multiply these. Order of operations says you have to do exponents first. So I have to evaluate this n 2 to the n minus 1 before I can multiply by the 5. Next, let's look at the 2, 8, 32, 128. The ratio, or how I get from one term to the next, is what? 2 times 4. 2 times 4 gives me 8, or 2 cubed. I could think of it both ways. But to get from 8 to 32, I would multiply by 4. So it looks like maybe it could start off as something cubed, but I would have that 8 cubed as my third term. So I'm actually multiplying by 4. 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. I'm sorry, 32 times 4 is 128. So the ratio is 4. My first term is obviously 2. So to write my formula, I put a sub n equals a sub 1, which is 2, times my ratio, which is 4, to the n minus 1 power. Not too bad. Moving right along. We're going to look at finding the nth term given the ratio and the term. So now we're given the ratio and a term. So the first example, again, is giving us the ratio and the first term. So I'm still using this formula. I don't know why that happened, but for some reason it scrolled up. Okay, so I'm still using this formula. So a sub n equals my first term, which is 2, times my ratio, which is 3, to the n minus 1 power. Pretty quick. So the next one, I am again using the same formula. So I'm looking at a sub n equals a sub 1 times r to the n minus 1 power. except this time I don't know what a sub 1 is. I am given a sub 5 equals 10, so I'm given the fifth term in my sequence, and it equals 12. So this is my a sub n. So I have 12 as a sub n, and n is going to equal 5. So let's plug those numbers in. We got a sub n is 12 equals a sub 1, which I don't know, so I'm trying to find, r, so times 3, raised to the n minus 1 power. Well, n is 5, so this is 5 minus 1. So I've got 12 equals a sub 1 times 3 to the 4th. So 12 equals a sub 1 times 3 to the 4th is 81. Now to get this a sub 1 by itself, I'm going to divide both sides by 81. So a sub 1 equals 12 over 81. It's a crazy looking number, but that is the first term of my sequence. Lastly, we're going to look at finding the rule given two terms. And if you recall back to arithmetic, this was the most difficult one. And there was a trick you could do where you would subtract the position by the other position, and then subtract the actual value, and then divide that number by the position. That doesn't really work so well with geometric. So we're actually going to solve this using a systems of equations. So I'm still using the same formula. I have a sub n equals the first term times the ratio raised to the n minus 1 power. And I'm going to set up two equations. So my first equation I'm going to do in red. I'm going to use a sub 2 equal to 5. So I have a sub 2 equals, I don't know what a sub 1 is. I don't know what r is. I know my n is 2 right there. So 2 minus 1. Oh, I wrote n. 2 minus 1. So a sub 2 actually equals 5. So we get 5 equal to a sub 1 times r to the first power. So to find out what a sub 1 equals, I get a sub 1 equal to 5 over r. 5 over r. That's my first equation. So let's write a second one. This time I'm using a sub 4 instead of a sub 2, so now I'm using this one, equals a sub 1, which I don't know, r, which I don't know, but I know that my n is 4, and I have minus 1. So a sub 4 actually equals 1/5. So 1/5 equals a sub 1 times r to the third power. Now I don't have to solve for a sub 1 here because I've already solved for a sub 1 on this side. I'm just going to take this value right here and plug it in for my a sub 1. So let's do that. Oh, this is 1/5. So I have, do some different color. I have 1/5 equals a sub 1, which is 5 over r, times r cubed. This r cancels with this one, and I'm left with r squared. So I get 1/5 equals 5r squared. So divide both sides by 5. 1 over 25 equals r squared. So r equals 1/5. So r equals 1/5. That's my ratio. Now that I have my ratio, I can plug that in along with my a sub 1. Or actually I have to figure out what my a sub 1 is, I'm sorry. Let's do it in blue. So my ratio is 1/5. So that's what I'm going to plug in 1/5. So a sub 1 equals 5 over 1/5. Well, when you divide by something, it's the same thing as multiplying by the reciprocal. So 5 divided by 1/5 is the same thing as 5 times 5. So the first term in my sequence is 25. So now I can actually write out what my sequence for the nth term is. So a sub n equals 25, because that's my first term, times r, which is 1/5 to the n minus 1 power. Let's move this up a little bit. shrink it so we can create more room for the next problem. All right, we're going to do the exact same thing one more time. So let's look at our two equations. We've got a sub 2 equals 4/3, so the second term in the sequence is 4/3, and a sub 5, or the fifth term in the sequence, is 32/81. Fractions, fractions, fractions. It's all right, we can work with them. So my first equation is going to be a sub 2. I'm still using this formula. I have no idea where that O went down here. Let me just go down and get it real quick. So we're still using the same formula. So I've got a sub n, which in this case is a sub 2. A sub 2 is equal to 4/3, equals a sub 1, which I don't know, r, which I don't know, to the n minus 1. I do know n is 2. So 4/3 equals a sub 1 times r to the first power. So I can just solve for a sub 1 or r. I'm going to solve for a sub 1. So a sub 1 equals 4/3r. Kind of crazy looking. So the next one I'm going to solve, I'm going to use a sub 5. So I'm looking at 32/81 equals, I don't know a sub 1, I don't know r. My n is 5, so 5 minus 1. So this becomes 32/81 equals a1 r to the 5th, r to the 4th. Divide both sides. Actually, I'm not going to do that. Let's just leave this one, just like we did the last one, and let's take this a sub 1 and plug it in. So now I'm going to take this 4/3r right here and plug it in for my a sub 1, and I'm going to solve for r. So let's do that in black. So 32/81 equals a sub 1, which in this case is 4/3r, times r to the 4th. These r's cancel, and I'm left with r cubed. So 32/81 equals 4/3 r cubed. To get rid of this 4/3, I'm going to multiply both sides by 3/4. So times 3/4 times 3/4. So now I get this 3 and this 81 simplify to 27, and this 4 and this 32 simplify to 8. So I get 8/27 equals r cubed. Take the cube root of both sides and get r equal to 2/3. So my ratio is 2/3. Now I can take this and plug it back in to figure out what my a1 is. So a1 equals 4/3, and this 2/3 is in the denominator. Well, 3 times 2/3, the 3's cancel, so I'm left with 2. So a1 equals 4/2, which is 2. So that's the first term in my sequence. So now I can use my formula to find out what a sub n equals. So a sub n equals a sub 1, which is 2, times my ratio, which is 2/3, raised to the n minus 1 power. And that's it. So just like with arithmetic, we solve these the same way using systems of equations. There's a little bit of some crazy substitution going on, but it shouldn't be that bad. If you have any questions, scroll back up and watch the video again. Pause it if you feel like you need to. If you don't have any questions, then you can move on to the classwork. 25 through 69, every other odd.